So I've been asked question 3 over here. I'll take a snapshot. I want to make sure I address the right question. So In Chow, do you have a microphone with you? Can you turn on your mic?
Yes. Can you hear me?
Yeah. So just tell me right or wrong. Okay. So you were asking why this is equal to 0. Is that your question?
Only the one below. I understand why the moment is 0, but I don't understand why the sum of force is 0.
Because this is known as static analysis. So what they are carrying out in static analysis, right, is they in static analysis, you always carry out that summation of forces in X is equal to 0. Summation of forces if there's a Y is equal to 0, and summation about moment in a Z direction at a particular point, for example, point A is equal to 0. Does that make sense to you now?
So sorry, sir, but if you look at question 1 and 2, why is not equal to 0?
Listen, it's very dangerous to compare one question to the other just to look at the pattern. You have to understand it fundamentally first. So what they are doing here is static analysis, okay? Now let's look at question number 1. As I said, I've not looked at question number 1. So question number 1 down here, right?
Yes.
Yeah, they let me have a look. They did not need to do static analysis down here. There's no static analysis. Right? They did not write summation about forces, did they? That is the reason why they did not use it. But it is equal to 0, okay? Right? So over here, let me show you why it is still.
Oh, that explains. Thank you.
Yeah.
I didn't see the part below. Sorry.
Yeah. That's why me posting the solution is helping you, but it's also harming you. Okay, harming you in the sense that you just follow the sequence what they are doing. That's harming you. Okay, helping you so that you will not get stuck in it. So the solution manual just look at key solution. What do I mean by key checkpoint? If you look at you still do your homework, okay, but check this answer. Don't follow them how they get it. Okay, you have to check this. Don't follow the method or don't follow them. Okay, and these are the key area that you have to check your answers. Not necessarily follow their entire sequence, because later on you look at when I teach, you will understand the way I explain to you how to solve the problem, but the book, the solution is not done by me. Okay, it's done by the publisher. Okay, and they have different way of solving it, but the final answer will always be the same. They solve it differently because they have different wealth of experience. Okay, they have experience in other places which we don't. Okay, they have, I'm not saying better or not, but they have different experience. Okay, so I hope that answer your question. Okay, right. So I'll leave this here. Okay, so today's topic, we are going to look at statically indeterminate structure analysis. If you look at your textbook, it's in chapter 2.9, and then we are going to carry on with thermal analysis. Okay.
Sir, can I ask you another question about the homework, or would that be at the end of the lecture?
Depend how long. What is your question?
I think it's a quick question. If you scroll down to question number 3's solution, sorry, question 5's solution.
Okay.
Question number 5, and I have a question regarding the static where you write deformation diagram. Yeah, right here. Yeah. deformation diagram. So in here, can you please quickly explain how did you get the slope theta and as well as a deflection in E? I think I'm doing it right. I just want to hear from you how did you come up with those fractions?
Now, again, as I said, this is not done by me. It's a solution manual.
I see. Okay.
Okay. So you're talking about this now, right?
Slope, yes. This with the slope and deflection E.
Okay. So let me quickly. So this is regarding question number 5. Okay. Right. So I will not need to calculate the slope. Okay. So what we can see now is we make an assumption. We assume member or assume member BEC to be rigid. So when we make the assumption, okay, when the structure deform, it is a straight line. Okay, it is a straight line over here. You can see down here, this is a straight line where I'm drawing in pink. It's a straight line. Okay. So member B prime, E prime, C prime are a straight line because we make an assumption there's rigid body. Therefore, E prime, B prime, E prime, C prime share the same slope. Right? Same slope, or in other words, we call or gradient. Okay, or gradient. Okay, so we can work out this is gradient is equal to change in y divided by change in x. Okay, so in this context, we want to find the gradient. Okay, so we don't need to use theta. Theta gradient is just a tangent. Okay, so they also call it the same slope. Okay, so now we know this. Okay, so share this same slope. We need to know what is this one. So I call it OB prime. Okay, and this one I call it O. I call it is there A? No, AE prime. Okay, and then I call this distance BE, and I call this distance B EC, and this entire distance is I call it BC. Okay, I call this BC. So you just form the equation. So the change in y over the change in x. Okay, so let me put this down here so it's easier for you to see. Right, so you can write the expression as this is equal to change in y at point B, right? So we can have OB prime divided by BC, and this is also equal to change in y is AE prime.
Sorry, sir, I think my thing is frozen. I can't see anything. I can't see half of the screen.
Can you see now?
All I see is the gradient delta y over delta x, and I see the member B prime EC where you wrote question 5, but I don't see past that. I don't see past the BEC.
Yeah, because that's what I'm showing you. I'm not writing anything else.
Oh, okay, okay. I thought you were writing. That's why, because the screen is just sitting. There's nothing there.
Yeah, I'm writing.
Okay, sorry about that.
So this is EC, right? Okay, so it's in terms. So if you look at OB prime, right? If you look at B prime, okay? So OB prime. So the distance we are taking is from here to here, and the distance taken is from here to here, okay? So this expression, right? So if you look at BC, the distance BC, okay, so we know that BC, I'm trying to relate to the distance over here now. Hold on. So BC, the distance is equal to 0.64, right? And then EC is equal to 0.44. And OB prime is equal to deflection of point C. Okay, is deflection of point C. Or if we look at deflection of B, OB prime is also deflection of B in the not OB prime. Deflection of B is equal to, so if you look at deflection of B, right? The deflection of B is this whole thing, right? Is equal to deflection of C plus by OB prime. Okay, so that is their deflection. So to find OB prime, you have to find OB prime. So I'll continue from the side to find OB prime is equal to deflection of B minus deflection of C. Okay, and then if we do AE prime or deflection of E is equal to deflection of C plus by AE prime. So over here, AE prime is equal to deflection of E minus deflection of C, right? So when you substitute everything into this equation where we have delta Y over delta X, right? So it's just a change of this. So OB prime, we have deflection of B minus by deflection of C divided by BC, which is 0.64. And this will be equal to AE prime deflection of point E minus by deflection of point C divided by 0.44. Okay. So they are just dealing with gradient over here. Okay, is that clear? Hello?
Yes, sir. Thank you so much.
Okay,
That helped.
it's just the gradient. You're not necessarily, they are also taking the gradient. Okay, so this is also delta Y over delta X. Okay, this is also the delta Y over delta X. We don't need to calculate the slope. Okay, from here we can immediately compute the answer already. Okay, so we don't need to calculate the radians. Okay, because the gradient, I mean the gradient and the slope are related. Okay, so I think this is the, if you look at the previous week, did I do an example of that? Hold on. Yeah, look at what I'm doing down here. Okay, so this, as you can see, right, relative to the question that you just asked, right, the theta is over here. If you follow the book solution, the theta is, but I don't want you to calculate theta because there's rounding error. Okay, do what I've taught you guys. Use the what? The gradient. Follow what I do is important. Are we clear? Does that make sense? Okay, so so use gradient. Okay, don't use the slope. I mean, you can calculate, but you will have rounding issue. Okay, right. So I'm glad that is clear. So let's go into our lecture with a statically determinate structure. Okay. So today I'm going to teach you how to solve structures are statically indeterminate. Okay. So what do I mean by structure that are statically indeterminate? What does that term actually means? Okay. I think there's